Hey, geeks. Welcome to another exciting episode of Rockin The Code World with dotNetDave. I'm David McCarter. I'm glad you're all here, and I hope you're having a good weekend. And just to let you know what's going on with this show is we're actually pre-recorded this show. So it's actually the end of September when we're recording this. We're airing it today on October 22nd because we had to do this not only because I'm going to India, but also my guest today, who I've been trying to get on the show for a long time. We could only do it on a weekday. So I'm excited to do the show. So please make comments in the comment section, but we won't be able to answer questions because this is pre-recorded. So I hope you don't mind. We don't do this often, but with somebody like Steven, I felt we had to do that. So anyway, today this is actually the first show of the third season of Rockin' the Code World, show number 68, October 22nd, and my very special guest is Steven Toub. I'm sorry, I said that wrong. Steven Toub. And I'm so bad with names. Simon knows that. So sorry, Steven. I'm so bad at this when I'm trying to talk and think at the same time. So anyway, he's a partner software engineer at Microsoft, and I've been trying to get him on the show because Steven is the man on code performance at the .NET framework. And so I've been trying to get him on the show because I always follow what he writes about. I always watch his sessions, and actually he was one of our presenters for the very first Code Quality Conference. So he has been on CSharpCorner before. So I'm really excited about this show because you all know that code performance is really important to me. I've been working on it all summer to show you all the latest benchmark test for .NET 7 and .NET 6. And I work on it every night. I was working on it last night, mostly because I'm still having issues with benchmark.net. It just disappears on me. So it's hard to track those things down. So anyway, let's get going on the show. The war is still going on in the Ukraine. Well, I'm guessing it's going to be when this show airs. So take a moment out and think about our friends in the Ukraine dealing with this a terrible war and all the casualties they've had there and all the losses of buildings and infrastructure and everything. So if you can support the people in the Ukraine, I hope you do. I really want to get back there someday as soon as this is over and they get at least one building good enough that we can hold a conference in. I really want to go back to the Ukraine because, you all know I've been to the Ukraine before. I loved it there. I really, really want to go back. I've been dying to go back ever since I was there in 2015. So let's get this over so we can go back and enjoy this beautiful country. And the food. The food is awesome in the Ukraine. I just love the food in Ukraine and the coffee. So, all right, I have a new article out. It's kind of new by the time you see this. It's speeding up the string builder using the object pool. I decided to promote this again because it's all about performance. If you didn't know, you can actually use an object pool with a string builder that actually does increase the performance. So if you do use a string builder a lot, check out this article because it will give you some important performance increase for that. And also make sure you tweet or email me your article ideas. I'm always struggling sometimes to come up with article ideas. I'm working on a really long article right now, so that's why I kind of been quiet for a while. And that article is all about where do you validate your data, and so it's taken a lot of time because I'm doing a lot of research on it. So if you have article ideas, please email them to me, and I'll get them done. So I'd like to welcome our guest, Steven. He's a partner. He's a partner software engineer at Microsoft. He spends most of his time on the libraries comprising .NET and on performance across the .NET stack. Welcome, Steven.
Hey, thanks for having me, David.
Hey, sorry I screwed up your name at the beginning.
Oh, the fact that you knew you did and that you corrected it, you're way ahead of most people.
I feel so bad when I do that. And then never mind, I won't get into it. I always had a hard time when I taught at the university saying my students' names. I would have really only called them by their first name because I just couldn't do the last names very well.
Not a problem.
So yeah. So how's it going? How's it going in your part of the world?
It's going well.
Where do you live now? You moved, you said, right?
I'm near Boston. I've
Boston.
been on the East Coast. I'm an East Coast born and bred guy. I've been here for many years.
Oh, so you never lived in Redmond?
I did. I went out there for a while, but couldn't keep me there. Came back here.
I'm originally from Delaware, and so
Okay.
yeah, I was born in Wilmington, and I also lived with my parents in Newark before we came to Arizona when I was right before I started 5th grade. So, and I was back there in 2018 visiting, speaking at a couple places, and also visiting some family I haven't seen in like 22 years because they don't come out here and I don't go out there, so it's it's tough to see my relatives. And I know we're recording this at the end of September, but are you going to get hit by this hurricane at all? Are you going to see some of this storm?
I don't think significantly. If we do, we might get a little bit more rain, but it's pretty far south of us, or at least predicted to be pretty far south of us right now.
Yeah.
But on that, thank you for accommodating my request to not do weekends.
Oh yeah. I was going to make a crack. Oh, well, now I have to. We don't get many comments during the Saturday shows anyway, so it doesn't matter when we do the show.
Perfect.
Yeah, because most of the people that watch the show are from India, and by the time this by the normal time we do this show, it's like 10:30 at night there. So, which it is right now for Steven. So, Simon. Gosh, I should have had another cup of coffee this morning. So I want to start off by, I don't have a list of questions. And so we're just kind of going to go and talk about all the cool stuff coming out, in .NET 7 that I know a lot of you all have been talking about all year. I know everybody's really excited. I know the first release candidate is out, and including for the SDK, and which I downloaded the minute it came out. And I have to say, I was talking at the top of the show about, all summer I've been working on benchmark tests, for .NET 6 and .NET 7 to prepare for the .NET 7 release, also to update my code performance book, and also update my code performance section on my website. And so since I have a lot of downtime right now, I've been working really hard on that. And I did mention I've been having periodic issues with benchmark.net. It's really been slowing me down. But I just want to say that, I think I said this when I had somebody on the show when .NET 6 came out, and that, the performance gains you guys did from .NET 5 to .NET 6, some of them were pretty amazing from what I saw, right? And, so when .NET 7 was announced, I was going, well, yeah, they're going to work on .NET 7, but, really what big improvements are going to be in that, because it's not a long-term support. But, from what I've seen, I'd see some pretty impressive performance increases in some calls in .NET 7.
Yeah, I think we don't really factor in LTS versus not LTS when it comes to the work we do on a release.
Yeah.
For the most part, our efforts in any given release are the same as in previous releases, regardless of how long support is going to be. There's a standard, every other release ends up being an LTS. Mm-hmm. But from a planning perspective, we really want everyone to be on the latest version, and LTS is there because some people require it. But we put our hearts and souls into every release, even if it's a short-term, support. When it comes to 7, some of the gains, we talk about micro benchmarks because they're easy to measure. It really requires looking at kind of the impact for the whole application to understand how much things actually move the needle. But there are some gigantic performance improvements kind of across the board in various libraries, and the runtime itself, in the GC, and the JIT. I put out a blog post a few weeks back about kind of surveying the myriad of performance improvements in 7, and we got some really nice feedback on Reddit, on Hacker News, on the Post, Twitter, wherever, people saying like, I wasn't, I see these micro benchmarks and I kind of waved them off, but I tried it and didn't make any changes to my app other than changing the version number, and it got 5% faster, or 10% faster, or 20% faster. And we've seen that with teams at Microsoft when they've upgraded from .NET Core 3.1 to .NET 6, or from .NET 5 to .NET 6, or people trying .NET 7, seeing that it lowers their cost of goods and services by 5, 10, 15% every time they update. Which is why we do this. It makes us really happy.
Yeah, and I've told people that ever since .NET 6 came out, is that all you need to do is switch it to .NET 6. You instantly get a performance increase. Yeah, you might have some issues with some of the NuGet packages, but generally everything should work. I never had a major issue of going from one version to another, even from Framework to .NET Core. I never had a major issue.
I mean, there's different buckets of where possible benefits can come from. There's a bucket that we focus a lot on, which is just change the version number, and all of the stuff you're currently using just gets better, right? That's one goal. There's another bucket of, we've added functionality that you can opt into using. Rewrite this portion of your code to use this new API instead of that new API, and you get even more benefits. There's another bucket, which is there are features that are there, but you have to kind of, without changing your code, you have to opt into them from a configuration standpoint. So put the JIT into a different mode. Maybe it's an experimental thing. Maybe it's something that we're supporting, but it's not quite ready. We haven't quite yet figured out how to make it kind of mainstream on for everyone. So there's all these different ways you can benefit from upgrades. There's a fourth bucket, which I've also seen a lot of people benefit from, which is, sometimes there are regions of your code that you just haven't touched in a while. And by forcing yourself to go back and look at them, you can find improvements in your own code, maybe taking advantage of new features, maybe not, where that forcing function of revisiting previous assumptions you made, previous decisions you made, helps you make your app go faster.
Yeah. And, before I forget, for those of you who, maybe performance isn't the biggest thing, on your mind or for your team's mind, but, one of the reasons I've focused on it for a while now is that, performance has always been important, because, performance, usually when we talk about performance, we talk about the performance that the user sees, right? And, but, this is really code performance. Well, what I'm really talking about is, why performance is so important these days is because, people are moving to the cloud, right? And because they're moving to these machines in the cloud, and the way that things are, you get charged for things in the cloud, every millisecond you spend, is you're being charged for, right? So if you can even decrease, like you were saying in the beginning, if you can even decrease that by 10, 15%, you instantly have a, cost benefit from that, right?
Yeah, I mean, that's one of the motivating factors that we see teams at Microsoft moving from their long-standing code bases on .NET Framework to .NET 6 or newer. Certain part of it is modernization, being able to take advantage of all the new features. We're basically not doing anything for .NET Framework anymore other than security fixes, right? So being able to take advantage of all the new stuff. But a huge one is how much it costs them. You can on the dev blogs Microsoft.com site, there are a bunch of teams that have been at Microsoft that have been starting to share their journeys about going to .NET Core, .NET 6, and whatnot, and kind of the process they took, how it went, the rewards that they saw. And there are some great examples of, I realize this is a much larger scale than probably many people watching this show, but teams that brought their services over to .NET Core and went from running on 40,000 cores to running on 20,000 cores with no reduction and even an increase in throughput and requests per second and so on. That's a huge cost savings, not just cost, but also environmental impact, right?
Yeah, that's true. Yeah.
Doing our part for climate change.
Yeah,
so,
we need to.
There are so many reasons that if you're not already considering moving to .NET Core from .NET Framework, you really should start thinking about it.
Yeah, I had a call, I think earlier this week with a company for a job interview, and they were saying, yeah, we're on .NET Core 3.1. And I go, well, if you hire me, we're going to have to change the .NET 6, right? I'm not going to work on .NET 3.1. Sorry. It's just, I left that behind years ago. And and I know that showing my attitude, but mostly it's because I want to take advantage of the latest things that that are in .NET 6 and 7, and because there's a big difference between .NET 3.1 and .NET 6 and 7.
Yeah,
huge. Right.
Yeah, I definitely I feel you, and I'm right there with you, and maybe even a little bit further beyond. I mean, we've already forked .NET Runtime's main branch to now be .NET 8, right? Because .NET 7 is basically done, other than really impactful performance fixes or security fixes or bugs that are regressions, whatever. And so, I was having a chat with someone yesterday. I was like, "Oh, you could just take advantage of this." Oh, wait, that's .NET 8. You're not. Yeah. So .NET 6 is so old to me.
I know. Well, I can kind of tell when you guys are kind of done with the current version, because right before that happens, I can't get anybody at Microsoft to respond to my emails and stuff, right? It's like impossible, right? Yeah. I can't get anybody to respond to my emails. I can't get anybody on the show, right? It's like dead zone there. And then all of a sudden, people are, responding to emails, they're going on vacation. Mads just got back from vacation. I'm going to chat with him next week. And so I can tell when you guys are kind of, it's done. Yeah. It's done. And now you're moving on to the next thing.
Yeah. I mean, we're on this annual cadence now with .NET where, we're shipping every November, and for .NET Runtime, because it's at the bottom of the stack, and changes to runtime can have a very significant positive or negative impact on everything above it. We locked down a lot earlier. So by mid-July, say pick a date, July 15th, like we've merged all the features we plan to merge. And then for the next month, it's kind of open bug fixing, stabilization, making sure we've dotted our I's and crossed our T's. Come mid-August, like we're only checking in things that are, going to really impact people. No new performance changes, unless it's like a big regression. We're not adding new features. So by that point, and then that's when we basically moved .NET Runtime's main branch to be the next thing. Open season on check-ins, but they're not going into .NET 7.
Yeah. And, when you were first talking, when you first came on the show, I was thinking, I maybe it's just me, but I'd be really interested how, your team, really hunkers down and tracks down a performance issue, and how do you fix it? Like, what do you guys do? You're all in around a laptop, and you all have your, it's like a medical group trying to figure out what's going on, and what programs you guys looking at, what dumps you looking at, I'd be really interested in how you guys really track down things, because that will help us track down things.
Sure. I mean, it depends on the kind of thing you're talking about. So let's say someone checks in something, and a few days later, it turns out there was a regression as a result of that change. So we've got thousands of micro benchmarks checked into a performance system in the .NET performance repo. And we're continually augmenting that. Every time someone tests something new, we're just adding more and more into there. And those are running constantly. On every time a new change gets merged in, like everything's running across every operating system, every supported platform, different hardware configurations, and so on. And there's an automated regression system that's trying to filter out noise and normal variance. But if it detects that there was a regression, that something consistently started regressing by 5-6%, whatever, it automatically opens an issue and narrows it down to the range of commits where it noticed the difference. And usually it's just a few commits. And within that commit range, it's pretty easy for someone to say, oh, the only one that could have possibly impacted it is that. And then usually that developer will get, called in and be like, so why? Sometimes it's expected. Like, anytime you're doing any kind of performance optimization, it is incredibly rare that it's only purely a win. Like the vast majority of performance optimizations improve something, hopefully by a lot, in exchange for hurting something else, hopefully by a little. And usually it's you're optimizing for the thing that happens 99% of the time, and you're making that 20% faster, and you're hurting the thing that happens 1% of the time, and you're making that 1% slower, right? And so these trade-offs are always there. It's very rare. Every once in a while there is a pure win, like, why are we calling this function? We didn't need to do that at all, just delete it. Like those are great changes. We love those. But even things that significantly lower algorithmic complexity or something, right? You might still be lowering algorithmic complexity, but increasing a constant that negatively impacts really small lists. Or we've been spending a lot of time recently vectorizing a whole bunch of things, which makes inputs that have more than, say, a dozen values way faster. But for 1, 2, 3, 4, like, you probably actually were better off with your open coded loop, because the overhead, just method call overhead, was probably more than you were spending, doing it normally. So these trade-offs are always there. So it may be that the developer gets pulled in and say, yeah, I knew about that. If you look at my PR, like, I even called it out. This is accepted. Sometimes the system just hasn't totally quiesced yet. Like, so we do all of our binaries go through a static profile guided optimization process where we run a bunch of canned scenarios and then feed that data into a recompilation that basically feeds into those binaries. And if you make a change that was impacting one of the methods that was benefiting from that PGO data, you may have totally thrown it off such the data is just discarded. And so your change ends up showing up as a regression until we rerun the scenarios with those changes. So it can take a few days for things to catch up. And it's not uncommon for one of these issues to get opened and for a developer to say, wait a few days and then get back to me, because I don't think it's actually a regression. Like, that just happened with a change that I made to dictionary a few days ago. So usually, like, it gets back to the developer. The developer often has it still fresh in their mind. They have some sense of what the problem may be. Sometimes the problem is obvious. Sometimes you need to open in a profiler and see, where are you spending time that you weren't expecting to spend time. Sometimes you're looking at the assembly code if it's that level of a change, especially if it's a JIT thing. You're going right to the assembly code to figure out where are we spending time. And there are different kinds of profilers that you'll try. You'll try memory allocation profilers. You'll try CPU profilers. You'll try really low-level profilers from Intel and ARM and AMD to kind of look at the assembly level stuff. Sometimes it's often just one developer looking at it. Sometimes if they get stuck, they'll pull in a few other people and be like, hey, I think I'm seeing this. Like, could you take a look? And everyone has their own favorite processes and their own favorite tools. And there's enough diversity amongst what people look at and their experiences and their backgrounds and their knowledges that there's usually enough to come to bear to figure out what happened and how can we fix it.
Yeah.
Most of the time, they're pretty easily, once we identify the problem, we can usually trivially fix it. Sometimes it requires a little thought. Every once in a while, we say, this just didn't pan out. We're going to revert. The hardest ones are the ones where we don't detect it at all. And then, 6 months later, someone comes and says, hey, the following thing is going wrong for me. And then we'll ask them for, a repro. We'll ask them for traces. We'll ask them for dumps, and we'll try and, root cause it from there.
Yeah. And I'm actually, one of the things I was going to say is that I really like that you guys are open to, people telling you these kind of things and working on it. For example, right now I'm going back and forth with, Mads Torgensen, because even when .NET 6 came out, I reported this to him, but now he seems more interested that, I found a couple issues with the record class and performance, mostly around serialization. And so him and I are going back and forth right now with an engineer trying to figure out, what exactly is going on and why is it that way. And so I appreciate you guys are open to the, people saying, hey, I see this, and you guys saying, oh yeah, Matt, that might be an issue. Let's work on it. And,
well, I mean, we have, we care a lot about making sure that everyone who's using .NET is successful. So if people report things to us we weren't aware of, we want to know about it. And enough people do that after some number of them, like the next time someone reports something, like, actually, we know about that, and here's why it's happening, and either wait for the next thing that's going to be fixed, or sorry, that's the way it is, right? And again, it's because of these trade-offs that we sometimes have to make.
Right.
And and it may be that we determine we made the wrong trade-offs and we revisit it, or it may be that no, like from where we're sitting, from the diverse set of inputs that we're getting, this is still the right trade-off, even though sorry that negatively impacted you. Here's a workaround, or here's a different way to approach it that gets you back on the path that we think is the golden one.
Yeah. And you guys use benchmark.net, right, to do your benchmarking? Yeah. Do you use anything else besides that one?
For micro benchmarks, that's what we use.
Yeah.
For larger scale benchmarks, there are other things that we use, in particular for things around ASP.NET, client server response. We have a tool, an open source tool called Crank, that we use for doing that. So pretty much all of our ASP.NET end-to-end benchmarks, for example, are based on that.
Yeah. Cool. So, so a couple of weeks ago, you released a blog post, which I about the .NET 7 performance improvements, which I really call a book. So longest blog post I've ever seen, I think.
It is a little bit long to be called.
I'd love to know how many words are in that thing.
I think it was about 75,000.
Wow. Yeah.
But that includes code samples. So like,
I
don't know how exactly that counts words.
Yeah. So let's talk about that. What's the big, performance increases in .NET 7 and what can, not only what can people look forward to, but, just what can people look forward to for the improvements for .NET 7?
Right. Well, there are about 230 pages.
Yeah, so
it's hard to say the big one. We can
pick a couple of your favorites.
Yeah, sure. A few of my favorites. So one of my absolute favorites, and this isn't actually a performance improvement, but it's the very first thing I talk about in the blog post because I think my favorite performance related thing in the release is there was the runtime. The JIT has long had the ability to dump out data about what it's been doing. But it's always been buried in debug or what we call checked builds, which are basically release builds that still include asserts and things like that. And there was a really valuable feature in there, which basically allowed the JIT to, you could ask the JIT to print out every time it JITted something, output a line to the console. So you could basically keep track of the work it was doing. And then you could also ask it to print out the assembly code for a given method or all methods in a particular class as it generated it. And for .NET 7, we've promoted that to being just part of regular release builds. So everyone who has .NET 7 can set these environment variables and see what methods the JIT is JITting and how it's JITting them and what code it's actually generated. So for people that are looking at understanding, like, I make this small change to my method and all of a sudden it gets 10% faster or 20% slower. Like, why is that? You can set this environment variable and see exactly what code you're running rather than having to attach debugger and, so straight from the JIT's mouth, you kind of get that data. So I love that feature. Yeah. There's a bunch of work done in the JIT around something called on-stack replacement, which is awesome. This harks back to a feature that was added in .NET Core 3 called tiered compilation. So one of the things we struggle with a managed language like .NET is this eternal struggle between startup time and throughput. And you want if you use a compiler like the C++ compiler or LLVM or something where you're doing tons and tons and tons of optimization, your compilation times can be minutes or hours, or like we don't have that kind of time in the JIT to apply every single optimization under the sun. But we do want to apply a lot of optimizations, and every one we apply increases the time that it takes to compile a method. And if you're doing all that stuff at startup, like that significantly increases your startup time. So tiered compilation basically serves as a balance between them. It kind of lets you have your cake and eat it too. The idea behind tiered compilation is we allow the JIT to compile things multiple times, tiers of compilation. The bottom tier, tier 0, is what we call minops. It's basically as few optimizations as makes sense. There are a few optimizations that change the code in such a way that it actually makes the JIT itself run faster. So it makes sense to include those optimizations, but everything else gets turned off. And so because optimizations are what takes the majority of the time to compile a method, by turning off optimizations at startup, essentially, it makes startup go way faster. As part of that, the JIT is then able to instrument that code to keep track of whatever it wants to keep track of, including, for example, how many times a particular method may have been invoked. And then it can say, all right, well, this particular method was invoked 30 times. I see that it's now actually an important thing to optimize for throughput. I'm going to recompile it. And I'm going to throw every optimization I have at it such that the next time it's invoked, and I've patched all the invocations back to the new version of the code, they're all just going to run a whole lot faster.
And that started in .NET 6, right?
That's .NET Core 3.0, I believe.
Oh, that's 3. Right.
The problem, sorry, my dog is...
no, it's okay.
Yeah. Just give me 1 second. I'll be right back.
I need your attention. Well, while he's looking after his dog, this is the thing which shows that we record at home, right? Things happen, and it's talking about things happen. They're actually construction workers are working on my building right now. So if you guys, hear any banging or yelling or anything, that's the construction workers outside. It was really bad last week. No, it's okay.
He was stuck outside. He was like, let me in,
let me in. I'm not part of the show. Let me in.
Exactly. Anyhow, so tiered compilation was introduced in .NET Core 3.0, but I mentioned that one of the things that JIT tracks is how many times a method is invoked. Well, there are certain methods that end up being very long running and may have only been invoked a few times.
Right.
Your main method, for example, is only ever invoked once. Right. And so, and if it's got a loop or something in it, it could be running for days. And if we're only tracking invocation counts, right, it's never going to get reoptimized. So up until now, basically, any method with loops or backward branches basically is opted out of tiered compilation. That means we're still compiling it as we always would have, and that not only impacts startup time, but there are other things that the JIT is able to do as a result of having executed something in tier 0 that allows the optimizations it can do later to be much better. So and these methods with loops were being opted out of that as a result. So for example, one of the differences between .NET Core and .NET Framework is long ago we prohibit in .NET Framework, you could actually, well, you shouldn't do it. You could actually use reflection to mutate static read-only fields. Even though they're read-only, you could use reflection to poke at them. Well, we disallowed that long ago in .NET Core. You don't do that. Can't do that. But as a result of that, the JIT can then trust that once a static read-only field, once the static constructors finish running, that value is not changing. And if it's a primitive, like an int or a bool or a whatever, like if it knows when it goes to compile something that value has already been initialized, it can treat it exactly as it would any other constant, and do constant folding and constant propagation and all the other kind of optimizations that it can do. So if you've executed a method in tier 0, and then you go to recompile it in tier 1, by the time it gets to tier 1, it knows that the code's already executed in tier 0, which means any static read-onlys that have been accessed, any static read-onlys have already been initialized, which means it can treat all of those as constants when it goes to compile tier 1. And so these methods with loops were losing out on that. So one of the things that's been added in .NET 7 is something called on-stack replacement. And the big benefit of this is it allows us to turn on tiered compilation even for methods with loops. And the idea behind on-stack replacement is in addition to instrumenting code for how many times a particular method is invoked, it's also monitoring how many times loops are iterated. And when it gets to some threshold, say 1,000 iterations of the loop, it says, this is pretty hot. I need to recompile this method. And at that moment in time, the JIT will basically generate a new version of the method, basically call into that other method, transferring over all the state from registers and whatnot, and then continue executing in that recompiled version of the method now with full optimizations employed. So this allows tiered compilation. You get the startup benefits, you get the optimization benefits for basically all methods and not just those that didn't have loops in them. So this is a pretty significant improvement. Folks will see improved throughput, improved startup time, and the like. So that's one of my favorite improvements in the JIT. But there are a plethora. There are many, many, many. There are a bunch of things that the JIT now, a bunch of things where the JIT's code gen for things just got better. But there are also many places where certain patterns are special cased, either the JIT recognizing certain sequences of things or special casing more methods where it can do something better than the method's implementation can. So for example, let's say you're doing starts with on a string. String dot starts with, in quotes, HTTP:// right? Now the method call has the method's implementation has no idea what it was being passed into. All it sees is that there's some substring I need to search for. But the JIT can see that you're using a literal. And as a result of using a literal, the JIT can do some really interesting optimizations. Like it can say, all right, I'm going to effectively unroll the comparison by treating the first, say, 4 characters, HTTP, which is 8 bytes, just as a U-long. I'm going to read that memory as if it was a 64-bit integer. And then all I have to do to implement the starts with is basically say, is the string, non-null? Is its length at least 4? And read those 4 characters as a U-long and compare it to this constant that the JIT baked into the ASM. And it's basically no more expensive to read 4 characters as a U-long than it is to read 1 character. And it's certainly less expensive to do 1 comparison than it is to do 4 comparisons. And so there are these optimizations that are applied then to starts with and ends with and equals and sequence equals, where a bunch more things have been made what are called JIT intrinsics. These are methods known specially to the JIT that it can optimize in certain ways. There's a whole bunch of those. One of the other really interesting sets of improvements in JIT has been around ARM. So, ARM64 was previously supported, but we had a really big investment in this release at getting the code quality up to being as good or better than x64. And this comes back to your comment earlier about running in the cloud and trying to ensure that no matter where you're running, like you're getting the best possible performance. Well, more and more people are taking advantage of ARM64 machines, hardware in clouds, since we want to make sure that screams when running on those as well. So there's a whole bunch of stuff in the JIT bucket. And then as you work your way up the stack, there are just pick your favorite area, and there are optimizations that have gone into there. So for example, working up the stack, if we look at strings, I mentioned some things that JIT does with strings. String processing, span processing has gotten better in a multitude of ways. For example, string.indexOf for a substring. It's a very common operation, right? I want to find the next occurrence of Steven in this text, right? So index of Steven. And previously, this was implemented as doing a vectorized search for, the S that begins at the beginning of Steven, searching for that character, and the next time I find it, doing a sequence equals basically for Steven at that location. Okay, it didn't match. Well, search for S again, then do sequence equals. As you can imagine, S is a pretty common character in text, and so we're very frequently stopping, starting, at least common inputs. So now what we do in .NET 7 is a same trick that's used in some other systems, is we do a vectorized search, not just for the first character, but also, say, the last character. So we're searching for S and N. What is that, 7 characters apart? I know my name. I think something like that. And that, the chances that you find an S is very, pretty high, but the chances that you find an S and an N, that number of characters apart, way lower. And that allows us to stay in that tight inner vectorized loop a lot faster, and in general get monumental performance improvements for the vast majority of searches. Now, I mentioned there are trade-offs. It's a little bit slower to search for 2 things than it is to search for 1 thing. And so if you were searching for something that you never find, like if I was searching for Z in a text, that had no Z's, we were better off just searching for the Z and not searching for, the A at the end of zebra as well. And so we pay a little bit more, call it, I don't know, 5%, 10% for that search in exchange for 20x or something on other searches, 20x improvements on other searches.
Right.
So I really love that one. I love that one in particular because I spent a decent amount of time in this release improving regex. Regex now leverages that heavily.
Right.
So we did a lot of, up until around .NET 5, regex had largely been untouched for like 15 years. It's basically
because no one understands it.
Yeah, well, lots of people use it,
Yeah.
but implementation-wise, it basically it had been a really kind of state-of-the-art implementation back in 2001 or 2002, whatever it was, but it just hadn't really kept up with the times. So in .NET 5, we made a whole bunch of investments in it that brought it back to being kind of on par or better than many of the other systems. Regex implementations
you can pre-compile your regexes now, right?
Yeah. So
or something like that, right?
Yeah, there are a bunch of improvements that have gone into .NET 7. We've invested, we invested a lot in .NET 5. We've invested a lot more in 7. In .NET Framework, there was a very rarely used piece of functionality on regex called regex.compile to assembly. And regex has long had this regex options.compiled option. What that basically says is, let me take a step back. If you just say new regex pattern, you're going to get an interpreter behind the scenes. So basically, whenever you run the regex constructor has generated a kind of a sequence of regex-related instructions about how to process some text. And then the interpreter, every time you call match or is match or whatever, the interpreter is interpreting those instructions against the input text. It does a fine job. But there are things that we can do if we were to pre-process it even further. So regex options.compiled has long used reflection emit to spit out customized IL for processing that particular pattern. So for example, it might unroll loops or bake in the structure of your pattern into the code that it generates. So you've been able to do that for a long time. .NET Framework's regex.compile to assembly, basically instead of emitting that IL into a dynamic method, and emit that into assembly builder, which it then saved out to disk. So it basically allows you to pre-compile to an assembly, and then you could use that assembly in, reference that DLL from your project and use it. That functionality never made it over to .NET Core, primarily because .NET Core doesn't support assembly builder.save. What we've done in .NET 7 is obviate the need for that entirely. And rather than, we've done a few things. We completely overhauled the actual IL that's being emitted to generate much better IL. And we did so at the same time as also implementing a source generator that instead of spitting out IL can spit out C# and kind of very human readable, nice looking C#. In fact, I can show a demo of it if you'd like to see that. And in doing so, because we're using a Roslyn source generator, we can basically generate the C# for your regex and have that go right into your assembly. So it's just part of your build. It's part of your project. You don't have to call regex compile to assembly as part of some other tool chain and then reference that DLL. We're just generating that source code and pretty reasonable source code right into your application, compiling it right into your assembly, which means you can debug it, you can step through it, you can read it and understand what your regexes are doing, in addition to all the performance benefits that come from being able to do this this effectively ahead of time compilation. So with regex options.compiled, even if we were generating just as good IL as the C#, you're still paying for that at startup time. Well, now it's all being generated right into your assembly. We're spitting out C#. The C# compiler is compiling that down to IL. The C# compiler is able to apply all of its optimizations as part of that transformation. So you're benefiting from all of those. If you're using something like native AOT where there isn't reflection emit, you get all the benefits of all these optimizations still with native AOT because we're not relying on reflection emit to do this at startup. And we're also, we're able to then write the code, the C# code in a way where we know the C# compiler is going to better optimize certain things. So we know it's going to optimize certain switch statements in a variety of ways that we can leverage. So let me actually show this in action because it's one of my you asked for my favorite features. It is one of my favorite features, and not just because I worked on it, but because I think it's really cool. So, previously you may have written something like regex, ABC, DEF, and you're, getting a regex as a result of this. I can use regex options.compiled. And again, this is all kind of happening at.
And that's how you get it to compile into your assemblies, by doing .compile?
No, this is if I was using it, I can, that as part of the constructor, it's going to do that reflection a bit. So instead of this, we've added this new generated regex attribute. Right. And you can saw we actually have an analyzer that says, hey, like, I can just convert that for you. So we'll switch you over to doing the...
Is that a source generator or just a normal attribute?
This is a normal attribute that ships in as part of CoreLib and as part of a system text regular expressions in .NET 7. But there is a source generator that is part of the .NET 7 SDK that is looking for this attribute and is spitting out code. So you'll notice I've got a partial method here. And if I were to remove this attribute, I've got a partial method with no implementation. So it's giving me a squiggle saying, like, there's no implementation for this. The moment I take away, the moment I add back this attribute, that squiggle goes away because there actually is an implementation for this. Right. And I can see that implementation. If I say, go to definition, let me put this over to the side here so we can see them both at the same time. You can see let me get a little smaller. You can see it's spitting out a whole bunch of code that is the implementation of this regular expression. You can see it's spitting out a method called try find next possible starting position, which is doing an index of for the C and the F in here, and then backing off a few characters. You can see it's trying to match at the current position, and it's doing that with a switch over the first character and then a case, and then it's checking to see if the remainder is BC or if it was D. And so, like, no matter what regex you throw at this, you get this, really nice.
So if you change that, the code's going to change,
and it's going to change live. So let me go back up to so you can see it. So let me start with an empty thing here. You can see the moment I've got it that it's not searching for anything, as the pattern matches the empty string. If I type out ABC, now it's calling this try next possible starting position, which is doing I mentioned index of earlier, right? This is doing an index of for ABC. If I change this to, let's say, A or D followed by BC, you can see it's now searching for just the BC because there was this, character class. So it's instantly updating. I can set breakpoints in here. I can F5 debug into this code. It's just code in my project. It's my code. Right?
That's really cool. I know.
And so in addition to all of the myriad of performance improvements that have gone into the release, there's also all the support for source generation. And there's a bunch of really cool things with regex. There's also a long requested feature has been the ability to have a non-backtracking engine in addition to the default backtracking engine. So there are different ways that regular expressions can be processed, sort of largely two high-level categories. A backtracking engine is kind of largely the way that you would think about if you were implementing it in your mind. Like with ABC or DEF, I'm going to walk the string and I'm going to say, is this ABC? No. Okay. Is it DEF? No. Okay. I'm going to keep going. Is this ABC? No. Is it D? So backtracking keeps going back to the previous point where it made a choice and then trying the next possible thing. And if none of those work, then it backtracks to the next point that it made a choice and so on. The problem with, and backtracking engines can actually be super fast. In particular for best case and even average case, they can be like stellar performance. The problem isn't best or average case, it's worst case. You can construct regular expressions that have what's referred to as catastrophic backtracking, basically exponential performance in the length of the input. So you could throw even a short input of like 25 characters or 30 characters and cause that regex to spin its wheels for minutes. This leads to things called regex denial of service attacks. So if you're using a backtracking engine, you have to either be really careful about what patterns you allow to be fed into your engine. They say no untrusted patterns, or you have to employ a timeout. So in .NET, you can you can use it pass a timeout to the regex constructor and basically say if this executes for more than time span 1 second, throw an exception saying this is running away from me. Don't use it anymore.
That's cool.
But in .NET 7, there's a new option, non-backtracking, which uses a completely different engine that may not have as good best case or average case, but guarantees linear throughput in the length of the input. So it doesn't have those fall off a cliff worst case stuff. And for certain patterns, especially with things that would have lots of backtracking, lots of loops, lots of alternations, it can yield even better performance. So that's also a really cool feature. And there's just, as I noted to your question, like with the best, it's 230 pages of this.
Yeah.
So
we're actually running short on time too. So unfortunately, I could sit here for hours and listen to this, but my brain is kind of getting all clogged up now because I have all these things I want to look at now. I've been writing stuff down while you've been talking. So since we are kind of running short on time, there's a couple of things I wanted to, at least two things I wanted to get to ask you before Simon gets upset at me. And going back to the, you were talking about the tiered compilation improvements and things like that. Is there anything that like we can do as a developer to configure that, or to make that better? Are there attributes we can use? Or
yes,
I think I might know the answer to it, but I want to see what you say.
So by default in .NET 7, tiered compilation is on. What's called quick JIT for loops is on. That's basically OSR. But there are a whole bunch of environment variables that you can set. Hopefully you don't have to. But there are environment variables that you can set for the various thresholds, like how many iterations does it take for OSR to kick in? How many method invocations does it take to, do you want to turn it off completely, setting .NET tiered compilation to 0? There are those kinds of switches. Our hope is that 99.999% of developers don't have to.
Yeah.
But if you find yourself in a pickle, you can do so. There's also an attribute that's in my perspective, poorly named attribute on the method impl options you can put onto methods. There's one called aggressive optimization. It's not what you think. Its name isn't actually like making this super optimized. It's basically opting you out of tier 0. So basically it's saying don't apply your compilation to this method. The big one, and it's unfortunately still opt-in, fully supported, but still opt-in for .NET 7. And this is something that people actually should try. And we've made it easier. Not only are there environment variables, but there's now, you can just put something in your CS proj for it. And that is, I don't actually have an example of it, so you can switch away from that. Sorry. But that is a dynamic PGO. So I mentioned earlier that we run all of our binaries through a static PGO process, meaning ahead of time. Dynamic PGO takes advantage of tiered compilation, where in addition, at tier 0, when the JIT does that initial compilation, in addition to tracking things like method invocation counts and loop iteration counts, it can track other things. Like, I see you're invoking an interface method here. Let me track exactly which concrete implementations are being used at this location, because the vast majority of places that you make interface calls, you only ever have one concrete type that's actually being used. It might be iList, but it's always a list, or 99% of the time it's a list. And so the JIT can track that kind of information, and then when it generates code for tier 1, it can special case things based on all that information it learned. So it says if 99% of the time that iList is actually a list, let me actually special case it and generate the assembly code so that it does, if type of foo equals type of list of int, then just call, non-interface, non-virtual list of t.add. And because it's doing a direct invocation, it can then even, it can not only devirtualize it, but it can also inline it. And then all the other optimization that can apply once something has been inlined kick in. So you can get some pretty sizable wins from dynamic PGO. My hope is that it'll be on by default in .NET 8. In fact, there's a PR out to make that happen. But for .NET 7, you still have to opt into it, either through an environment variable or the CS proj switch, which if you're interested, you can read the blog post. It's included there. Absolutely, that is something that people should try and configure and see and provide either find that it's awesome or find that it's not and provide feedback on that, because we'd love to hear that too.
Okay. And I also wrote down a bunch of stuff I need to benchmark that I haven't been benchmarking. Like I don't benchmark regex, so I'm going to have to do that now. I don't think I'm doing index of. I'm going to have to do that. So the last question about at least what this topic is that, we've been talking about all the great things, about performance and that's coming out in .NET 7 and what's been happening lately in .NET 6. So what's like one thing people should absolutely avoid doing because it will kill performance? There's one thing that comes to mind, like, it's what's one thing that you see people do that it's just, shouldn't be doing?
I mean, there are lots of things. A lot of them end up being things that we could probably point to ourselves as the root problem with this, but like we have designed APIs that make it to fall into pits of failure. So, for example, JSON serializer. It's really handy type. It's got this simple JSON serializer.serialize method. You can pass in options to it. So you can say, serialize, blah. And some people write new JSON serializer options and configure it right there. Because why not? It must be a small little type. Like that allocation is not going to hurt me. What they don't realize is that we end up attaching a whole bunch of state behind the scenes to that options instance. So when you use JSON serializer.serialize, we will reflection emit a custom implementation of serialization for the type that's being serialized. And then we need to cache that somewhere. We cache it on that options instance. So if you end up creating a new options instance every single time you call serialize, not only are you paying the cost of that object allocation, but you're paying the cost of all that reflection emit happening over and over. And it can be like 1,000x. So, that's something that we've mostly fixed via some global caching in .NET 7. But even that, there's still some overheads there. So just being careful about like, do I really need to allocate this every time, or can I cache it if I'm just using the same thing over and over? Put it into a static field. Am I allocating way more in general than I need to?
Yeah.
Am I using the best method for the job? Am I using an algorithm that has a much larger algorithmic complexity? It's order n squared instead of order n. These are all things. But the number one thing that people could do to improve the performance of their code, just profile it. Like take a typical scenario, run it through a profiler, and see what you see. And unless you've heavily optimized your code already, guaranteed things are going to pop out. You're like, wait, why am I spending 20% of my time in this function that I thought was never invoked? Or why am I allocating like a gigabyte in this function over here? All of that stuff is generally invisible unless we've memorized all these patterns. And you throw it under a profiler and all this stuff pops out at you, and you can make significant inroads in performance regardless of what version of .NET you're on, just by paying attention to that sort of stuff.
Yeah. Well, I'm so glad you mentioned profilers because, I write about profilers. I speak about them, whenever I'm in front of people, I talk about them, but I have yet to go to a company that actually does it. Right. It boggles my mind that nobody does this that I see in like the business world. Right. I know you guys do it because that's part of, creating libraries and stuff like that. So profiling to you is like, that's just a natural thing, but I cannot get teams to do it or pay me to do it. They go, well, literally at one company, I said, well, before we release this, I want to run this through a profiler. And they go, well, we don't want to pay you for that. And I go, really? Come on. And I actually did it on my own because I was curious, but this is the kind of attitude, unfortunately, a lot of companies have, is they just don't see the value in that. And so I'm so glad you mentioned it. And I do that JSON serializer problem that you just mentioned in my open source project. So there's more work I have to do now. You've caused more work in 1 hour that I need to do because of me learning things than any other show I've ever done. So
sorry, but not sorry.
I know. Well, I gotta let you go because Simon's getting upset at me. Not upset, but he's saying, Dave, it's overtime now. So I'm so glad you came on. I'm so glad we were able to work this out. And I for one am so glad that somebody as smart as you is on the team and doing these improvements. And
well, they're not all me. There are many smart people
I
on
know.
the team. And to be clear, like the team is a global, like it's not just people on the .NET team at Microsoft. .NET is open source. Yeah, I think something like 20% of the improvements that I call out in the performance post came from people outside of .NET. So it's everyone is to thank.
Yeah. So I'm glad you're there. I'm glad your team is there, and I'm glad of all the improvements you've been making the .NET because that for at least for me it gives me more things to maybe talk about when I go to a company and they're looking at maybe not doing .NET or something, and I can say, well, how about have you looked at performance, right? And I'm so glad you guys are really working on it, because I know I'm sure it's always been a big deal in .NET, but at least in the last 5+ years, I can feel that it seems to be a lot more attention to it. So
there absolutely is. I mean, performance was always important, but not a driving factor.
Right.
And now it is very much a driving factor.
Right. So I'm so glad about that. I hope everybody who's watching the show is glad about that and appreciate all the work that you and your team have been doing. So the last question I ask all my guests before I let them go is not a code question, and that is, what do you do for fun that's not coding?
Hang out with my family, play with my dog, go running. Yeah.
Well, cool.
Sing. I love to sing.
Oh, really?
Yeah.
Oh, wow. I'll have to remember that when I'm next time I write a song, I need a male singer on. But I do that because there's more to life than coding, right? And I want to make sure that geeks out there know that geeks already know what I do, right? Because I talk about it all the time. But I want to bring that out that we don't sit at home coding all day, right? There's a work and life balance that we all have to, depending on how close it is to release, right?
Right.
But there's always a work-life balance, and we have to maintain that. Otherwise, it can lead to bad things. And so anyway, thanks a lot for being on the show. I definitely want to have you back sometime in the future when we can work it out on a weekday.
Thank you.
And I was going to ask you about .NET, but we're out of time now. So, but thanks a lot for being on the show.
Thanks for having me.
Thanks. Well, man, that was I was paying a lot of attention in this episode because I was writing things down and learning things. I love episodes where I'm really learning a lot. And I know I teased Steven about he's caused me a lot of work, but that's okay. I always want to improve things, especially in my open source projects, and I always want to improve things in the things that I write and things like that. So that's why I've been trying to get Steven on the show for a long time, because he's the man at Microsoft when it comes to this kind of stuff. So I appreciate him so much for being on the show. And speaking of performance, I mentioned it earlier that not only do I have a code performance book out that I'm working on the new version right now, but a lot of the new stuff for the new book is already out, and it's at this location on my website. A lot of it's free. A lot of it's a subscription model where you can pay $4.95 a month and read all these kind of articles that you want. So I hope you go check that out. I've been, like I said, I mentioned a couple times on the show, I've been working really hard this summer in September to get this information out before .NET 7 comes out. So I hope you'll go check out this section on my website. And of course, I definitely hope that you subscribe to it. Also, don't forget, my coding standards book is out. I hope you go pick it up. I know a lot of teams need coding standards, and so that's what this book is about. It's been around since 2005, and so go check it out. It's available everywhere. You can get it on Amazon. Here's some geek humor that I've experienced in the past, and that it's, wow, a different error message, finally some progress. I feel like this all the time, even recently, where you struggle with an error message and struggle, and then you get to a new one and go, oh wow, at least I fixed the old one. Anyway, as always, I hope you will help me help the kids in India. By the time this comes out, I'll be back from India. I'll be back from the Voice of Slum, seeing how, the money that I've raised for the NGO orphanage has helped them. I'm bringing them some computers, along with Joe G is bringing some computers to help the kids out. So we're doing our part, but you need to do your part. And there's 3 ways you can do that. You can buy my current code performance book. 100% of the proceeds go to the Voice of Slum. You can go to this GoFundMe page that I've set up. You can donate there, and then as soon as it gets to a good amount, that I'll donate it to the orphanage. And you can also just go to voiceofslum.org and donate directly. You can donate money. You can buy clothing for the kids and school supplies for the kids. And so I'm sure I'll have my next live show after India. I'll have some things to share about the Voice of Slum. So I hope you will help me help them, because if you've never been in a slum in India, it's quite a moving experience. And we as software engineers have the ability to help these kids. And so I hope you will help me help them. Okay. So I don't know, because this is pre-recorded, I don't know what our next guest will be, so I'm not talking about that. So please be safe and listen to your medical professionals about COVID-19. We're still having, hundreds of people die in America every day from COVID. I'm going to get my 3rd booster shot tomorrow before my trip to India. And in the meantime, you can also please donate blood at your local blood bank. All the blood banks are in a dire shortage right now. They're actually in a really big shortage. I've been hearing from the San Diego Blood Bank. So it only takes 30 minutes of your time, and 1 donation can help 3 of your fellow humans. And so I hope you will go donate blood at your local blood bank, which I will be doing this coming Sunday after this recording, as long as my blood iron is okay, which it wasn't last time. As always, make sure you email suggestions, comments, guests you want me to invite on the show to Rockin The Code World at CSharpCorner.com. And I want to thank my guest Steven from coming on the show. I'm so happy he was able to come on the show, and I will see you next time.